All right, you guys, it's the Monday before your exam, and we are down to kind of just like the last couple videos to watch, just because maybe there's something we haven't talked about in a previous video or that you've done on homework that we just kind of feel like one last chance, right? One last chance to see something, hear something, and like get a last minute reminder in your head before you take your test. So this is from the year 2011. It's a non-calculator problem since it's problem number 6. And it's a really short stem of the problem because all they really do is tell you that you have this function f and it's defined by this piecewise function. So draw your brace and you have your two branches. So your top branch in for f of x, your top branch for f of x is 1 minus 2 sine x for all x is less than or equal to 0. So everything including 0 and to the left of 0 and to the negative numbers, right? And f of x is defined for the rule y equals negative e to the negative 4x power for all x is greater than 0, or to the right of our origin, if we were thinking about like being on the origin. So this is a part A, part B, part C. So part A is to show that f is continuous at 0. So isn't that our 3-part definition of continuity at a specific point, which we've done once before. So you should pause the video, you should do this problem on your own, and then go back and see how you did on it. Part B and C are kind of newer. There are questions that we've definitely done, but maybe not piecewise. So see how you can do for those. Okay, so try it on your own and then rejoin. So remember that once you rejoin and that 3-part definition of continuity, and it does say to show that f is continuous at x equals 0, which means it is. It should meet all 3 parts. You just have to like explicitly go through the 3 parts and keep your work organized and make sure you conclude it for them. So isn't part 1 of the 3-part definition that the value has to exist, right? F of c has to be defined, or f of c is existing. So if our value is 0, and I think about a piecewise function, oh, what do you know? 0 is the critical point where the 2 pieces break apart. I'm only really defined where I equal 0 for the top piece. So wouldn't I substitute in 0 in place of x only in the top piece? The function value itself exists, so it will pass the vertical line test only in the top piece. Well, if we have trig and we're on a non-calculator part, it's probably going to be an angle in radians that you can do using your unit circle. So isn't 0 radians the same thing as 0 degrees? And our order pair here is 1, 0. And the y coordinate is the sine value. So wouldn't f of 0 equal 1 minus 2 times 0, sine of 0, 0, which would give us 1. So we know, because we got an output, the only way it's not defined is if you would get something that gave you division by 0 on a rule. But we got an output, so we would say f of 0 exists. And move on to part 2. So part 2 of the 3-part definition is that our limit as x approaches 0 of this piecewise defined function, you got to take the limit of something, of f of x, exists. But in order for the limit to exist, and if 0 is where they break apart, don't we have to do the left-hand limit and the right-hand limit and make sure they equal, so the two-sided limit, this is the notation for the two-sided limit, we know is going to exist. So if I said the limit as x approaches 0 from the left, doing that little negative in the upper right-hand corner, from the left would be the part where it would be a little bit less than 0 into the negative numbers, and wouldn't that be this top piece? So now instead of defining what I'm taking the limit of as f of x, I'm going to put the top piece, of 1 minus 2 sine of x. Well, what's the first thing that we try with limits if we're approaching a c? Oh, the first thing we try is direct substitution. So if we're trying direct substitution, why isn't this going to work? Like, I'm fine. I can drop the word limit. I can plug it in. It doesn't matter if it says 0 from the left. You're just plugging in 0. And we already evaluated that sine of 0 was 0. And then that's going to make this whole part go to 0. So wouldn't this answer be 1? And then we're going to do the limit as x approaches 0 from the right. Well, if we're to the right of 0, we're a little bit beyond 0, which means x is greater than 0, so aren't we on the bottom piece of our piecewise function? So instead of putting f of x right here, I want to define the piece that it satisfies. So wouldn't that be just the single term e to the negative 4x power? So I don't even really need parentheses there because it's one term, but I'm just trying to emphasize. So can't I do direct substitution? Again, I'm not going to get division by 0, so I drop the word limit because I'm evaluating the limit. Negative 4 times 0 would turn into just 0, but that's up in the exponent attached to a big base e, and isn't any base to the 0 power equal to 1 by definition? So our left-hand limit equals our right-hand limit. Doesn't that mean, therefore, the two-sided limit as x approaches just 0 with no little notation in the upper right-hand corner of our piecewise function f of x also equals 1. And that means that this exists. So part 2 is also met. So then part 3 of the 3-part definition is, do the 2 answers that you got from part 1 and part 2 match? So does the limit as x approaches c, our c is 0, of our function, f of x, does that equal f of c, our c is 0? Does that equal f of 0? Well, yeah, our limit answer was 1. Our function value was 1. 1 equals 1. So therefore, f of x is continuous at x equals 0. Remember to restate your x value, because they might give you a function that's not continuous everywhere, or like maybe there's another like weird spot. And if you don't say at the x value, then you might be saying something false. And if you say something false on the AP exam, they don't give you points for it. Okay? So we've done that 3-part definition one other time, and this is giving you like another like last minute shot at it, because it's just something that's harder to remember. 3-part definition of continuity was way back, remember, like in the very first real calculus unit we did in chapter 2. So like September-ish. All right, so part B, part A, B, C. So part A is done. Part B, for x is not equal to 0, express f prime of x as a piecewise defined function. So doesn't f prime mean to find the derivative in general in terms of x? Find the value of x for which f prime of x is equal to negative 3. Well, before I can find where f prime of x is equal to negative 3, I gotta just find f prime of x. So if we're taking the derivative and we have a rule, we're like, okay, just take the derivative with the rule like we know how to do. But it's weird because it's on a piecewise. And remember that the extra credit multiple choice assignment for this week, if you choose to do it, is going to have a lot of piecewise stuff on it. So maybe this is also good for that. So if I have a piecewise defined thing, as long as I'm not right at this value of 0, maybe the derivative doesn't exist right there. And that's why they're saying for all values where x does not equal 0, like maybe it's a corner, maybe it's a cusp, maybe it's a spot where you're actually, I mean, we know it's continuous because we just proved it over here, but on a different problem where you're discontinuous, and like if you had like a jump discontinuity or something going on, you got to be continuous before you're differentiable. So maybe it's not differentiable right at that break point, but everywhere else it would be fine. So that's why they're saying for all values that don't equal 0. Well, don't overthink it. You're just going to take the derivative and do a brace and do a top and bottom piece. So when did the derivative of 1 go to 0? And when did the derivative of negative 2 sine x? Well, the constant negative 2 would just stay out in front. The derivative of sine is going to be cosine. And wouldn't that be just for x less than 0? Because we're not including that critical point where our pieces are defined in different branches. The derivative of the e to the negative 4x for the bottom piece. Well, isn't the derivative of e to the something, e to that something, times, ooh, it's chain rule, the derivative of the exponent, because that's like the inside. It's really a composition. If it were just e to the x, the derivative would be e to the x. But if it's e to the negative 4x, it's e to the negative 4x times the negative 4. If we were doing integrals, definite integrals with boundaries or even without boundaries, the integration answer would be the reciprocal. It would be negative 1/4 times e to the negative 4x. But if it's derivatives, it's times that derivative answer. And wouldn't this be for all x greater than 0? Because we're not including the 0. That's how you're going to write that derivative of a piecewise. So now that we know that, rereading, it says find the value of x for which f prime of x has to equal negative 3. So don't we like have the derivative answer, we just don't know the x or the x's that give us that derivative answer. Well, I don't know which x on which branch might give me the negative 3, so I guess I better try both of them. So I'm going to take the negative 2 cosine x, the top piece's derivative, and set it equal to negative 3, and try and solve this equation and see if there's x's that give me the negative 3 as the derivative answer from the top piece. But then I'm going to take this piece, I'm going to rearrange it, negative 4 times e to the negative 4x, and set that one also equal to negative 3, and try and find the x or x's that would give me a derivative answer of negative 3 from the bottom piece of the derivative. So you do have to actually know some algebra here, be able to solve and isolate your variable. Well, I would divide both sides by the negative 2 to get rid of this coefficient in front of my tray. Before I can find my angles in radians, then that are going to give me whatever trig answer, I better at least isolate the trig part. And a negative divided by a negative would turn positive, and wouldn't it be 3 halves? And then wouldn't you be thinking, oh, I'm really doing inverse of both sides, but I don't have a calculator. So I'm kind of in my mind saying, remember inverse is the same as arc cosine is the same as inverse cosine. What angles in radians give me a trig answer of 3 over 2 when I take the cosine of it. Well, square root of 3 over 2 gives me angles, but not 3 over 2. And you guys, isn't 3 over 2 the same thing as 1.5? And remember, like if you try this on your calculator, it gives you that error message and says out of range. It has a domain issue. Like think about the cosine graph, the cosine wave. Doesn't your cosine wave bounce back and forth between +1 and -1? It starts up, you coast down. I'm never going to get an angle that gives me an answer up here where I'm at 1.5, but there's nothing up there. I never hit the cosine wave up there. So actually, this one's out. There are no x's that are satisfied on that first part of the derivative from the piecewise. There's no x's that are going to give me -3 from that piece. It's out of range. So I'm going to go to another piece. Kind of starts similar, where I got to get rid of this coefficient in front. So negative divided by negative will give me a positive. The 3 would be left in the numerator. The 4 would be in the denominator. That doesn't reduce, so I'm just going to leave it as 3/4. It's non-calculator. How do we get rid of a big base E? Oh, you got to think about inverses. This is important for college entrance exams a lot of time. Don't we get rid of a big base E? By taking the natural log, because that's log little base E. And whatever we do to one side, we got to do to both sides. And I am going to use parentheses to like overemphasize the fact that we're taking the natural log of the whole fraction, 3/4. So the natural log and the big base E cancel, and that would get me to -4x equals the natural log of 3/4. And typically you would go, okay, then divide both sides by -4. We can already have like this natural log function, and we already have a fraction going on. So maybe like instead of that, how about we multiply by the reciprocal and put that in front? So how about x equals -1/4 in front times the natural log of 3/4. And some of you might be going, well, remember that property of logs, and can't I show this using the quotient property and separate them as individual natural logs with subtraction in between? And the answer is yes, but you don't need to. I mean, it's just a value, it's just a number. It's non-calculator. This is multiplied with -1/4, -2.5 in front. It's just a number. So you're down to a number, you're done. That's all you need to do. So part B, done. Moving on. Part C, find the average value of f on the interval from -1 to +1. And I think I'm going to need more room, especially since this is non-calculator. So before I do part C, let's go over points real quick on A and B. So A is 2. Typically, if you have to do the 3-part definition for continuity, it's going to be 2 points. So you get 1 point if you knew that you had to do one-sided limits. So you knew that you kind of had to do the left-hand limit and the right-hand limit, because when you're finding the limit as x approaches 0, this is where it breaks apart, so you have to approach it from each side individually. And then you get 1 point for the rest of your analysis and answer. So did you do that the function was defined, and that the function value f of 0 equals 1, and the limit answer also equals 1, so you knew it was continuous? Like, did you complete it with all 3 parts? So 2 points for part B. Or for part A. Part B is 3, so the 3 points on part B are 2 points for the derivative in terms of x. So my thought is you probably get a point for each part. So you can definitely earn 1 out of 2. And then the third point is, did you find the right answer for x so that the derivative would equal -3? Did you rule the one out and find the other one? Stop, because it's not a calculator. You wouldn't have a calculator available to you. So that means we're going to actually have 4 points left for part C. But since part C is going to be a little bit longer, I'm going to go ahead and erase so I have a lot more space. I'm going to keep my function right here and kind of erase the 3-part definition of continuity work that I was showing right here. Okay. All right, so part C said the average value. So that's not AROC, it's not the average rate of change, it's just the average value. And I mean, it has nothing to do with anything with context. So the fact that like they're saying find the average value of f on the closed interval from -1 to 1 means you're supposed to be running fave on that closed interval. And it's not like you have to like interpret that because it's some context problem. It's just like flat out do fave. So we know this is our closed interval, so this is A and this is B, and we know our formula for fave. Hopefully it's on your guys' like list of things to know, and you might want to have that piece of paper ready with you tomorrow for your exam. And if A is -1 and B is +1, isn't it 1 over B minus A? So 1 over 1 minus a -1, right? That's the first part, times, and then you do the integral from A to B. So you're like, oh, okay, so go from -1 to +1. But you guys, how are we going to do that? This piecewise function breaks apart at 0. So if it breaks apart at 0 and we have like different pieces, whether we're to the left of 0, which would be from -1 to 0, or to the right of 0, which would be from 0 to +1, are we going to have to like do each piece separately? So I don't know if we've ever shown you fig with piecewise. So it's kind of like this part that's going to reduce to a +1/2 is going to be hanging out in front, and then I'm going to do some brackets because we're going to have some separate definite integrals. So the definite integral from -1 up to 0, where the critical point breaks apart, that would be of the top piece, of 1 minus 2 sine of x, then I'm going to do that one separately with respect to x, plus the next part from 0 up to +1, using this bottom piece, of e to the -4x with respect to x. And then that first part, that 1 over b minus a for fave, just stays in front, which turned, like I said, into a +1/2, right? 1 minus a -1 would turn into 1 over 2. Well, this is non-calculator, so you can't just math 9 it. You actually have to find each part, antiderivative. So calculus is beautiful. Isn't the antiderivative 1 with respect to x going to go up using the power rule to x? The -2 is just a constant multiple. It stays there. And the antiderivative of sine of x. So you're thinking backwards in your head. Okay, what trig function gives me a derivative of sine? Isn't it going to have to actually be negative cosine? Because cosine's derivative is negative sine since it's a co-function. So this came from a negative cosine. And then aren't we evaluating both of these terms from -1 to 0 since it's a definite integral with boundaries? And I'll clean that up in a minute and show you plugging it all in. Plus this next part. Well, if you need to show it, it's u sub. So if you need to show the u sub, I would do that. We didn't really do that integration by parts unit because we ran out of time. And if we had done that unit, probably a lot of you wouldn't need to show it. Maybe some of you know the answer is going to be -1/4, which is the reciprocal of the derivative, times e to the -4x. But if you don't, this is your u sub, right? You would let u equal -4x, what's up in the exponent, and the derivative of u with respect to x would equal -4. But that means -1/4 du equals dx. So I can get everything into terms of u. So this part is going to replace this part. And because there's boundaries, Mr. Herney and I likes that method 1 where you change the boundaries as well. So the lower boundary used to be x equals 0. If I plug that into my u statement, the u stays still 0. My upper boundary or my upper limit used to be in terms of x equals 1. But in terms of u, -4 times 1 would turn into -4. That's why I always kind of like label them, because they actually end up being backwards, so I'm going to have to negate that. So if I pull the -1/4 out in front and write everything in terms of u, my lower boundary in terms of u is 0. My upper boundary in terms of u is -4. This is now e to the u and du because I moved the -1/4 out in front. But since 0 is bigger than -4, I'm going to have to reverse that and negate that definite integral. So while I'm doing that, I'm going to kind of clean this part up. So the 1/2 stays out in front. This turns into x plus 2 cosine x, evaluated from -1 to 0. Would this part negate, then the -4 would still be there, and now we can go the normal way from -4 to 0 of e to the u du. So that's really going to turn into a +1/4. X plus 2 cosine x evaluated from -1 to 0 plus 1/4 isn't the integral of e to the u, just e to the u. And because we changed our boundaries to be in terms of u, then we can keep those boundaries 0, other way, -4 to 0. So now we're actually ready to just plug in all our numbers. And remember, it's not calculator. So once we plug in our numbers, we're stopping. So the 1/2 is going to stay out in front. We plug in our upper boundary first. The antiderivative evaluated the upper boundary minus the antiderivative evaluated the lower boundary. Well, if I plug in 0, this part would be 0 plus 2 times cosine of 0 minus, new set of parentheses, plugging in -1, -1 plus 2 times cosine of -1 plus 1/4 times e to the upper boundary, 0, minus, this is only one term, so I don't need parentheses, 1/4 times e to the -4th power. And honestly, you could stop right there. It's all numbers. -1 is not an angle you recognize in radian mode that you can take the trig value of anyway. So you would have to have a calculator for that. Cosine of 0 is equal to 1, I guess, if you want to replace that with its value. So this part would go to 0, this part would turn into 2 times 1, which is just 2. But we've kind of heard in different spots, like, it's okay if you leave it in terms of trig. I'm not 100% sure on this. This would turn into a +1 if you distributed the negative, and it'd be a -2 times cosine of -1. But I mean, that's like not anything we can do. E to the 0 goes to 1, so that part would stay plus 1/4 minus the 1/4 times e to the -4th. Or maybe you move the e to the -4th down to make it a positive exponent instead of a negative exponent. But honestly, it's just numbers, so you can stop. Okay, I think this part is perfect. So I already told you this one was 4 points. So let's go over how those 4 points are kind of distributed. So the 4 points for C, you get 1 point if you knew to do the definite integral and split it up from -1 to 0 with the top piece of the piecewise and from 0 to 1 of the bottom piece of the piecewise. So you kind of get 1 point for having both definite integrals. And if you forgot about the 1 over b minus a in front for fave, you wouldn't lose that point. You could still earn that point. And that's not even integrating it yet. It's just like the setup. Okay? So you get 1 point for that. You get 1 point for correctly doing the antiderivative right here. X plus 2 cosine x. So if you messed up that the antiderivative sign went to negative cosine, so your sign was wrong, you missed that point. You get 1 point for correctly getting down to the antiderivative here, the 1/4 e to the u. If you did not use u sub, so you have 1/4 e to the -4x, that's the same. That's just like if you leave it in terms of x and you'd have the x boundaries instead of the u boundaries. So that would be fine, okay? Kind of a point for each antiderivative. And then the last point, which is going to be the hardest point to earn, is your answer where you've replaced all your numbers and you haven't lost any of the negatives or anything and did the evaluation part of fundamental theorem of calculus correctly. So since we haven't really done anything with the piecewise, that was like important, I think, to see just in case you have something piecewise on your exam tomorrow. Okay? And there's going to be another video to watch for today as well.